So we want to solve a three-variable system of equations using elimination. So to do so, we're going to do the same process we used in Algebra 1 when we solved two-variable systems of equations. But now, rather than focusing on getting eliminating a variable and then solving for the other, we're going to have to do that twice. So we're going to eliminate z here, and then we're going to eliminate z here to give us two different equations. So let's start with the top two. I'm going to go ahead and copy these. Okay. And then we're just going to combine by adding those two equations together. 2x plus x is 3x. 3y minus y is positive 2y. The z's cancel out, and 10 plus 16, or 6 is 16. So that's our first equation in two variables. Soon we're going to bring that over and put it into a system of equations. Now let's look at the bottom two equations. Oops. So here, we cannot eliminate z right off. We need to do something to get the z values to have the same and opposite values. Same absolute value, opposite actual values. I'm going to multiply the entire top equation by negative 3. Negative 3x plus 3y minus 3z is negative 18. This equation will remain completely unchanged. These cancel out. 3y minus 2y is just y. Negative 3z and positive 3z cancel out. And negative 18 plus 20 is 2. So y is equal to 2. Coming over here, we already have a system here with this set up. 3x plus 2 times 2 is equal to 16. So 3x plus 4 would be equal to 16. Subtract 4 from both sides of your equation. These cancel out. So 3x is equal to 12. We divide both sides by 3. So x is equal to 4. So we found our first two. So if we were setting up our ordered triple, it would be 4, 2, and now we need to find z. To do that, we can go back to any three of the original equations here. In my mind, this one is the easiest to work with. So we have x minus y plus z is equal to 6. That means if we subtract x and add y to both sides, we find that z is equal to 6 minus x plus y. Plug in what we know. 6 minus 4 plus 2. That's going to be 2 plus 2, so z is equal to 4. So our ordered triple is 4, 2, 4. The last thing we want to do is we want to make sure that we are not just solving, but we are taking the time to check. So we can plug these into the original equations. 2 times 4 plus 3 times 2 minus 4 is equal to 10. 2 times 4 is 8. 3 times 2 is 6. 8 plus 6 is 14. 14 minus, oops, that should be 10. 14 minus 4 is 10. That one checks out. Let's look at the second one. 4 minus 2 plus 4 is equal to 6. 4 minus 2 is 2. 2 plus 4 is 6. So this checks out. Last equation. 3 times 4 minus 2 times 2 plus 3 times 4 is equal to 20. That's going to give us 12 minus 4 plus 12 equals 20. 12 minus 4 is 8, and 8 plus 12 is 20. So we have verified our solution is correct.